All right, super. Well, anyways, what I thought I'd cover today in this half hour is what I think is the most useful tips I've gotten to address situations like these, that I've encountered. Luckily, I haven't gotten a ransom notice yet, but so we won't have much time to talk about that anyway. I'll do that next time. The first piece of advice that actually I received and strive to follow is this one here. The fact that the faster you want to go, the further ahead you want to be able to see. So why, I live in Montana now, is why I want this rig for myself, right? And notice the exhaust pipe on the right. Yeah, that's what I need. There's another piece of advice that I got is the earlier you act, the more options you will have. And so to put these maxims to work as a team, I offer this visual way to look ahead in time. And so that way we all agree on why we want to do some things, right? Especially ahead. And so the idea here is that we begin with a look at usage history over time, if we can. And I found that the most effective leaders focus on the lead time rather than who to fire. I'll talk a little bit more about this blameless situation of the culture of blameless in terms of innovation and speed. The partly here is what we want to do is to project velocity of future usage. And that's how we look ahead in time. And so testing is a key part of this to verify what are the real limits so that we're not arguing about hypotheticals, about what might happen or where the is or not. And so what testing gives us is the ability to test, to identify those real limits to stop the disagreement. But the nice thing about this, now that we know when things are going to blow up and at what level of capacity, we then can take a look at what the buffer of reserve capacity that we can get. And then from there, we figure out the lead time. And the lead time is really where I think leaders, again, focus on. Rather than like who did what and when, what should we have done? I think the key part of what I try to do as a leader is to look ahead and see, hey, how much of a runway do we really have here? And when can we really act? Can we do this soon? Can we have more options when we are working with the future rather than looking always the way back? I mean, the history would give us an idea as a usage, but it's really projections that really get us there. And more importantly, if we're talking about disk space, we're talking about really any resource that we have today, a lot of that could be automated. And like, for example, SSL certificate renewals. When was the last time that your system, I'm talking about production system, just blew up because somebody forgot to update those SSL certificates? Well, that should never happen because there are methodologies, there are methods and services that we can use to have that done automatically where it's a no-brainer. Okay? Now, if you have a certificate that's in risk of expiring, talk to your operations people and see if you can automate that stuff. In fact, any of these resources that we have work with, go ahead and figure that out, right? And figure out what can you do to automate that. That's what SRE is all about. Again, the leadership, I think, means that we focus on the right, on this list on the right. Because what happens when time is spent on assigning blame rather than the items on the right side here? This is why research has shown that organizations that seek to use blameless communication patterns move much quicker and are more innovative. So part of what I was talking about here in terms of security is we're going to have crises that we'll surely have. It may not be a ransom notice, but certainly like, things blowing up, we're going to hear it. So one of the things that I found is there's some good advice from crisis communication professionals or public relations kind of people. So we'll talk about notification and monitoring systems in a minute, and holding these statements. I think thinking ahead of time and figuring out what is it that we're going to say when things happen. even given the current situation, even if we don't have SSLs, figured out, what can we say about that? So that way we are prepared to talk about it. So it's not just preparation, is not just about the technical aspects. I think that there's a lot to be said for figuring out what we're going to say and then working with the team to say, hey, if we're going to get a ransomware notice, what's going to happen? What is the sequence of events that we're going to have? If we're going to run out of disk space, what are the sequence that we're going to have? If we run out of CPU or memory, what can be done? And so the big part of all of this, I think, is every person knowing what the role they play and how they communicate in crisis situations, and especially during crisis situations. Here is what we call an incident response, where instead of the status of, if you're a director, then you get to speak more, you get to interrupt more, versus that's in the industry, they know that doesn't work in a crisis situation. What we want to do is to have a designated general incident manager for those incidents, and that's the person who is going to work with the entire group. Like, for example, you would have a commander that implements and executes experiments. We would have a technical leader that's focused on problem solving. A lot of these, by the way, this kind of a structure, these incident response, is as a result of analyzing how they have figured out the response to airline crashes in the United States and throughout the world. They have a specific protocol. They have people standing by with equipment, and it's very fascinating, I think, looking at that. So all of this, by the way, is not something I've made up. There is a reference, like, for example, this one, that ISO 27002 talks about information security incident management. So I would recommend that you take a look at this, because if you don't, you're handling it wrong probably, right? So at least you've got a basis of saying, hey, maybe we should take a look at this, because they've spent a lot of time figuring out what should happen during a incident in a way that actually gets results. Okay. Now, going into the communication aspect of it, is one of the biggest problems that I've run into is, when there's an incident, where's that developer? We need that developer to talk to. What happened? Right? Big issue, and there's a solution for that. The person who really looks at these is, there's a SOC, or a Security Operations Center, that works 24 hours looking at dashboards, looking at what they call SIEM, security op, and they look at these systems and looking at metrics that get generated over time. And I'll talk a little bit more about these, how these metrics get there. But they work with the central operations team that looks at the operations of the center. Now, so those two, are the ongoing 24-hour situation. Now, some companies, especially smaller ones, they would combine the central operations team with the security operations center and call it a single center. This is very much like, what we used to have in terms of network operations center, because they knew that, okay, network is only one part of the whole situation. So we really ought to call it security operations center, because it looks at more. Yeah, but the problem with security operations center is that, a lot of things happen that isn't so much security that you need to have actions on. So that's where the ServiceNow system comes in. And again, there are other alternatives here, but ServiceNow is the biggest one in the block. That's the one that I happen to know about. So the idea there is that they would have a request. The request was streamed through ServiceNow, and it's a SaaS system. It used to be on on-prem kind of a system, but today, they have a SaaS kind of model. But the key part of this is they're working with incidents. And what we do before production is every group would have a queue of these incidents and requests that they would look at. And every morning, when we do our DSM, the first thing we look at is, what are those incidents that have cropped up? And then each of these incidents and requests would mark a particular configuration items, such as if it's dev, if it's QA, or if it's production, then that's a different configuration items. And some teams, they would put these configurations items that would include different parts of the system. Now, the idea here is that developers would look at this group of queue and then update it and says, okay, I've worked on it, I'm closing it out because I fixed it. But the problem is, what happens if they are not on the terminal? That 20 minutes a day, they go to the restroom or sleeping. So the idea here is that there is a thing called VictorOps, an application, but recently Splunk bought them, and then now it's called a Splunk on Call. And there's a mobile app that basically is a kind of a wake-up call system for developers, similar to what a old beepers, pagers used to do. So that way, it's on their system on there. So the idea here is that you could send an email to the service now, and then it would create an incident. The reason why that is because email could be missed. It could, a lot of things can happen to the email, like, go into a bad queue, and then you'd be gone. So, but the idea of the service now, the reason why it's needed is because it's got a secondary approach. It's got a never forget kind of a situation because it's running on a SaaS system, and they would remember. So it's not like, oh, I didn't get your email, sorry. It's in there, and you just can't forget about it. And it will escalate if you don't answer within this prescribed amount of time. And they have these fancy logic rules that are in there in terms of escalation, so that way things get looked at on a timely level. You can't get that with email. So the idea here is that alerts would be generated from the Splunk system, and there are new advances about these alerts, AI systems that various vendors have come up with that will identify the alerts that come up, rather than having a security operations center operations team looking at a dozen monitors on the screen. That doesn't work. We're far over that now, is that now the computer has to be the one that will sort through all this stuff in real time and then come up with alerts for humans to deal with. And it usually has to be a limited number rather than just 50,000 calls, or notices or emails. It doesn't do us any good. It has to be very focused in terms of here's what I think you need to do, and so that way it's a very defined and very clear. And that takes a lot of intelligence. Thus, the AI and machine learning system in Splunk and other vendors. Now, here's the problem that I've seen with the application of this. So what's the bad side of this? Well, applications used to be available if it was running on another machine, a separate machine, that developers would just basically get a AWS account, and they would then look at it and be able to SSH in, do whatever they need, and life is good. But it doesn't work that way anymore because, why? It's containerized into a Kubernetes, and that's shared, running in a cloud. And so what happens is the central operations team, and a lot of them may come from the old style operations where they had control of everything, and they would then lock out the developers to say, you don't have access to this because we're in charge, okay, on this. And I think that's really the anti-pattern that we're seeing quite a bit. And so, developers feel disenfranchised. So a lot of times is the middle ground or the conceding is the operations team and says, all right, we have all these Kinesis logs and audit logs, VPC logs, CloudTrail, CloudWatch. All right, you get those guys set up. We'll send these logs over to the Splunk system, and there's a collector that we set up that the logs can go in there, and those logs can then be analyzed to create metrics for everybody to see. So the trouble with that is then developers can get and do some queries against those logs, but if they get access, a lot of places they get zero access into the Splunk system, or they haven't been trained to how to use those queries, because those queries, a lot of times they're like, 5 pages long on there just to make sure, just to get to the specific items that you're talking about. And so what happens is that the same thing with the metrics. Are they able to see the same metrics that the Security Operations Center people look at? And more importantly, do they have access to those metrics in the dev environment? So that way, when they're working with this in dev and QA and staging. A lot of times they completely are outside of this Splunk system, so that way they have no practice. They have no idea that any problem is going to develop in production because they never get access to it. So that's the major problem I think I've seen with Splunk. And so the other thing is that the new style, there are some new technologies that are very valuable in terms of what they call X-ray and what AWS calls X-ray diagnostics, but other people call it tracing, which really tells us why. By, you know, in those of us who are working with performance, we used to have like Dynatrace, or still have Dynatrace, where we could trace exactly what happens down all the way down the line of what's going on. Don't make it into Splunk. So when we're looking at the logs in Splunk, and even if we have access, usually they don't include a lot of the details that we need in order to figure out what exactly happened. So the idea here, the really basic principle, is that if we're going to analyze, if we're going to figure out what is wrong and figure out what is the issue with specifics, we have to look at logs, because usually it's after the fact when we get involved as developers jumping into a system. Okay. Now, I want to stop here for a second and see if there's anybody have any questions.
I think Todd probably would have some fantastic questions if he's here, as he's also with Splunk. Todd, are you there? Otherwise, it'll have to go into, okay. Let's leave it to the Q&A. So let you keep on going.
We'll talk about our Q&A. Okay, so now the question is, how do we keep developers from doing stupid things? Right? Because you know, locking them out is not a question, right? And they would, the biggest problem is that the SOC team would call me. I've had a call once from a SOC team. They go, okay, this is the problem, you need to fix it. I'm going like, what system is that? And he says, okay, this is the one. And I'm going, well, I haven't been working with it. And certainly I haven't been working with it in production because we're completely froze out of it. I don't know what's going on. And so that happens a lot, quite a lot, because even if we can get to it, a lot of times developers don't feel included. They don't get to the meetings. They don't know when things go into production and so forth, which is why the modern approach today is to have a single developer go in and control the whole thing, with support by the Security Operations Center, who then looks over their shoulder rather than putting up a shield or putting them behind a wall, right? And the nice thing is, given enough training, Kubernetes is allowing a individual, given enough training, to be able to run the whole show. And that really, I think, is the power of Kubernetes. So when you have like a central ops team that takes over a Security Operations Center that doesn't show any information, I think that's an anti-pattern. So that's just me. All right, so now the question is, what do we do about it? And there is this new thing that's called Terraform with policy as code. What that means is that when we work with Terraform, again, there's other options as well, but Terraform is what I've been working with. And the nice thing about this policy as code, and this is through in Kubernetes, it's called a OPA you know, with their different language. But the thing is that what the idea here is that instead of a security person reviewing every single line of code, instead of IAC code, which is, you know, Terraform, which brings up the servers given a set of configuration item files, it would generate these provider, you know, these the entire setup in the you know, in AWS or whatever. Now there's this new thing called not new, but it's, you know, available, completely open source, by the way, on this, if you give it Atlantis. Now Terraform has a new thing called Terraform Enterprise as part of their Terraform Cloud, which does this in a more automated way. But you get this set up, and you know, you would start from VCS or a GitHub, and then, you know, put your files in there. It's the HCL files is a The only difference with that is that the HCL files allow you to put comments, whereas in YAML you're not. So the idea here is that Terraform is saying, oh, we're a multi-cloud, multi-vendor, and the reason is because the names of their commands, like TF, this is abbreviated. You say Terraform init. You can also change it to say TF init as well. So the TF init is the same, regardless of whether you're on Google Cloud or AWS. And that's their claim for But if you are switching from AWS to the to Google or Azure, you would need to rewrite these files. There's no such thing as saying, okay, you've got all this definitions of AWS, and now I'm moving to Azure and I'm changing everything, right? Automatically, so you have to rewrite the whole thing. So the idea, each provider is a different cloud, like AWS versus Azure. And so when you do the initialization, it sets things up. And what Atlantis provides you that the core Terraform free stuff does not, is that it has a separate program or service that you can run to do a PR create. And that PR create kicks off Atlantis, and Atlantis then would kick off the plan for you automatically instead of you typing it down. Of course, you don't need to use Atlantis, but Atlantis allows you to do this extra PR stuff. Right? And so that one creates an execution plan, and it figures out the dependencies for you. And so the extra sauce here, the secret sauce here to get policy as code is this additional step of Sentinel apply, which has several provisioners, such as if you have a remote provisioner, it can call this TFE or Terraform Enterprise in the back end. And what that would do is it looks into each organization's workspace, per environment, and it looks into these Sentinel policy files, and then it would execute the HCL file, would call these Sentinel files and apply them. And what that allows them to do is then you could see whether things pass or not. Like, for example, some of the policies would be making sure that you have tags on all of your items, so that way you can get some accounting of really who's using the money. That's usually the first one that people want to implement. The other one would be like, and I'll show you an example of this, is how much money you're going to be spending. The other one is then you would have a PR would then approve, as you go through the different versions, you keep rotating, make sure everything's okay with your plan. So you don't need to have a meeting with a security person to review, because this is done every single time, every single change. Even if you change one character, it would go and apply this, because just like any other CI/CD, that's what you do. So at the end, it will approve it, and then you would do apply, and apply then sets up your entire configuration as EC2 instances, or whatever else, and all the different networks. It sets everything up right there on this. And so what it does is also the apply also creates what they call a TF state, so that way the next time you make a change, it will know, okay, this is what's currently running, and then it will make a change. And we call this a declarative approach, because rather than you saying, if this is running, then add this, if there's 5, then add 2, to get 7. If you just say 7, it will just automatically make sure there's 7 for you. And that's really the wonder of this declarative approach there. Additionally, a lot of people then use what they call local exec provisioner within Terraform, and that will then kick off Ansible to install various applications within particular servers. So you could do that dynamically rather than baking it in. You would do that dynamically with Terraform, or with Ansible, add those programs in. Again, Ansible is also a declarative situation, so that way, dynamically, you could say, this is what I want running inside this particular server. Okay? Now, one thing I really like about Terraform Enterprise, and again, I get no money for this, is that it's a one thing that would allow me to know the costs before they are incurred. So in other words, as part of the Terraform Atlas running there, or Atlantis, I mean, running. Not even Atlantis. This is really part of Terraform. You tell me that this load balancer is going to cost me $18, and if I make a change, it says, okay, this is another $18 that you're going to have. So this change is going to cost X amount more than your previous configuration. So it outlines everything before you send it, because with just AWS by itself, it only tells you if you've already spent the money, and usually, you got to chase after them, and that's kind of a tough thing. And by the way, if you're an individual, you cannot talk to anybody in AWS. You have to go through an email, and that really sucks. All right, so now I see 27 minutes into, I've got half an hour left. So I don't have a lot of time to talk about this, but I would suggest that you guys take a look at this, and I'll give you the whole deck that you can work with. And that's got a whole timeline in terms of chaos engineering to work with. Now there are several options that you have for chaos engineering. But the idea here is that what my basic idea here is that it's not just Gremlin, who was created by the person who worked at Netflix. There's also a Apache Litmus and several others. Even Alibaba has their own that they created back in 2017. And so the idea here is that you would use something like this Buggy app, for example, and what you do is you would go in and use this program, invoke this program, and there are functions that you can do. Like it will come out with, then it'll eat up all your memory. So you have a problem with Java heap, you have a memory leak and CPU spikes and all that. And then with block threads, it would create those problems for you. Or you can use, the Gremlin and all that has a lot of the administration, the history already for you. And some of these others also have a planning feature where you could figure out, okay, now given these various runs, here are the different ones that we can do. So the idea here is the takeaways coming out is that, beware of lead times, because again, lead times give you options that you won't have down the road. Automate the actions if you can. Figure out where developers can get traces as well as logs and metrics. Experiment with the different changes, because if you experiment with the incident response, actually sitting there and says, okay, here is a situation, I want to play through what they call a table war game, and say, okay, we're going to have a crisis communication, and you would have somebody sitting there observing the situation and say, okay, this is not blameless communication here. And so that way you can really learn ahead of time to handle these situations before. So anyway, so that's what I know. Okay. And so anyways, I can stop now and then take some questions.
Absolutely. Well, thank you, Wilson. As always, it was amazing. And so I'm going to just ask you a couple of things actually first, and bring back, hopefully we've got Todd as well on the call. But first of all, obviously, great reminder on the last second around Gremlin. I love Gremlin's products. You can keep on camera, but and I also love what he's done. So check out the podcast link, which I will put into the chat. But I wanted to get you and Todd on for a second, and I'm going to bring, actually, Iran can join in as well if he's available. I know I've just been chatting to him on Slack. So I got this email, and to keep me honest, I have emailed you both a screenshot of my inbox to prove this actually is the real world. But my client has just been on the phone to me while you guys were panicking because he's just had this
real time.
At the exact time you were talking, right? Which is an incident. And it's come from Cloudflare to say that he's just had a latency of 16,000 seconds, failover, over 2,000 failover instances on his pods, on K8, and 7.7 seconds of recovery time for each one of these. And he's sat there on the phone to me going, we've just rolled out to Australia, and we're planning to go to North America and take on another 100,000 people. do I have a problem? And so I thought, well, I just sent him a message back saying, it's all right, I've got Todd on the line, we'll jump on Splunk, we'll have a look, we'll get it fixed. It's probably Cloudflare, but, it's a real world thing, right? Is that this last mile, this network infrastructure component, there's a real problem here. And I think this kind of approach to how you actually deal with incidents is really, really interesting. And so what's your kind of thoughts, your first initial thoughts about receiving an email like that, and how would you kind of go about thinking about answering it?
So you say that like it's a bad thing. I'm kidding. Well, one thing I found very helpful is this thing called Thousand Eyes. And I think it's been purchased by Cisco or somewhere. That's been very helpful because I've got monitors in each of the offices that we work out of. And that will tell me, okay, in Sydney, there's a problem, right? There's a network problem, so it's going to happen, right? So that's the situation. So having alternative networks helps. Like for example, I have a AT&T subscription as well as a Verizon, hopefully a Starlink soon, and so that way, we've got some options. And I would recommend people to do that as well, so that way, it's kind of a backup.